Hello, I'm Frank Lamb from Automation Consulting, and I'm starting a Siemens project here that I'm going to be calling the Odyssey project. I plan to start from the beginning, creating a project, and kind of let it grow organically into something like my Allen Bradley samples project that I use in my classes. I hope you enjoy it. As I mentioned, I'm going to start from scratch here. I'm assuming that most of the people that watch this video are already familiar with the simple basic parts of PLC programming: normally open, normally closed contacts, timers, counters, that sort of thing. As I mentioned previously, I really don't know where this project's going to go exactly yet, but I'm going to start the project here. I've double-clicked on the Schematic Manager. You can see it open up here. This particular Schematic Manager is version 5.6, which is required to run on Windows 10. So you need at least that. You can see an old project that I've got here, and that typically happens when you open up the Schematic Manager. You will get the last project that you had open. You can just close it this way, but the manager is where everything pretty much comes from. So we're going to create a new project. There is a new project wizard here. I don't use that. I'm kind of used to using this older style. And this is where you give it a name. And since I called this the Odyssey project, I'm going to go ahead and type in Odyssey here. And I'm going to keep it in the S7 projects folder, which is pretty much the generic place where all the projects end up. It's a good idea if you're creating projects in a plant or something to keep them in a projects folder, something like that, that is specific to the project you're working on. Just a little bit easier to organize. So here's my project. You can see there's really nothing in here yet. Kind of looks like a little box full of paper or something on the icon. You right click and say we want a new station, and this is going to be, I can name it pretty much anything I want to. We will call it Odyssey CPU. How about that? Okay, so as soon as we do that, now we've got this, and this is where we create our hardware. So if I double click on hardware, I get a nice generic box. One of the things that a lot of people don't particularly like about Siemens is that there are a lot of windows that open up. So I kind of tend to tile things and organize them as I need them, close them as I need them. You'll almost always need the manager, and of course it's present down here on the taskbar along with a bunch of other things that I have open on another screen. The first thing you need if you're creating a 300 system is you will need a rack. And the rack, oddly enough, is simply a piece of aluminum. So if I double click it, you can see here all the spaces that I need for my CPU and my input and output cards, that sort of thing. The CPU can only go in slot 2. Slot 1 is for the power supply. The power supply does not physically connect into the CPU. You have to wire it in. So it really doesn't care if you put a power supply in there or not. I'm just going to pick one. And as I pick the power supply, we'll pick a nice 5 amp standard power supply here. Notice that it does highlight it in green, so this is the only place that you can put it is in slot 1. And it gives a little bit of details down here at the bottom. It gives the full part number, it gives the ampere rating, and the voltage. If I were to pick a different one, it would give a slightly different description down here. I can either drag this power supply over or double click it as long as it's highlighted. So I've double clicked it. That puts the power supply in there, and again, this is really just for documentation. It doesn't matter whether you install this power supply or not, and if it's the wrong one, the CPU won't even know it. Okay, now we're going to pick a CPU. One of the ones I use in my classes pretty regularly is the 314C. I also do happen to have a 315. The 315 doesn't have any I/O built into it, so I think I'm going to pick that one. Notice that there are 3 different 315s here, and then there may be other versions, right? These are firmware versions inside of these folders. So there's a lot of different 315s that you can pick. This PNDP means that it has both Profinet and Profibus. DP is Decentralized Peripherals, which stands for Profibus. So I'm just going to pick one here, and we're going to be using the simulator, so I'm going to pick the highest possible firmware. And again, I can double click it, or I could drag it over. Generally here, you want to make sure that your IP address and subnet mask matches your computer, because if your mask doesn't allow your computer to communicate with the processor, it won't work even in the simulator. So I believe my network address here is 192.168.3 something. We'll check just to be sure. And we'll go to Network and Internet Settings. Let's see, change the adapter options. There we go, finally came up. Go into the properties here, and we want to make sure that we're compatible. That's why I'm doing this. And you see I've got it set on obtain an IP address automatically. That wouldn't work in a real plant. So I'm going to set this up the same way I would in a real plant. 192.168. And I tend to use the .3 series here. So we'll go .3. And this computer, I believe, is usually .10. Yes, .10. I'm looking up on my whiteboard here to see my address. So, something about the mask. This 255, 255, 255 means that my processor would also have to be on 192.168.3 something. Obviously something that's not this computer. So, because I'm going to put it on a different network, I'm going to go ahead and change the mask to 252. This is a pretty common thing that we do both in my classes and for automation training. Automation Training is a company that I contract to, and they tend to use 192.168.1 and 192.168.2, and I tend to use the 192.168.3 area and sometimes the 0 area. So I'm going to use the 0, which means this 255, 255, 252 will actually talk to 192.168.0 anything. So that's the point of changing this mask slightly here. So I'm going to say OK. We'll close this, close this, close this, and now I can be compatible with this 192.168.0.1 if I change the subnet mask to the same 252. And the best place to explain this is somewhere else. I'm going to do another module on Ethernet addresses to explain how some of this works. But we do not need to set up a subnet next yet. Slot 3 is reserved for interface modules. So the only thing I could put in here is an IM. And I'm not going to do that unless I were to put another rack in here, but this is where I'd get it from. So the first place that I can put an input card is over here. So I'm going to pick signal modules, and the first place I can put it is in slot 4. So I'm going to just pick a generic input module. We'll pick a nice 16-point module, 24 volts, pretty standard stuff. And as I show here, I can either drag or I can double click. And it even says here, I can only put it in slots 4 to 11. Okay, so we'll put it in slot 4. Notice that it filled out the address here automatically. Let's see if I can find that. There it is. So I am at 0 and 1 for my inputs. That would be I 0.0 through 0.7, and I 1.0 through 1.7. Sorry if you hear a lot of ums and ahs and things like that. I am not going to be doing a lot of cutting in this project. I'm just going to let it roll. So you may hear some misspeaking. Okay, we're going to pick a output card now. That's also in the signal modules, and you can see here that was a DI. So here I want a DO. We'll pick a, let's see, DO16, that looks good. And you can see again the particulars down here. So we'll drag this over, slot 5. Once again, you can see the addresses. Because I'm in slot 5, my outputs here are going to be Q4.0 through 4.7 and Q5.0 through 5.7. Everything in Siemens is byte based. So this takes up 2 bytes because it is 16 bits. We'll put an analog card in here. And that again is in the signal modules. You can see the AIs. You can see a lot of different things in the description here. How many points? So an AI2 12-bit module, an AI8 13-bit module. We'll take an AI8. And 13 bits is pretty good resolution. You can see we go all the way up to 14 and 16-bit resolution here, but I'm going to drag this over. It's not real hardware anyway. So I'm just going to drag it, and I can drop it up here, or I can drop it down at the bottom. My addresses here would be PIW288 through PIW302. So each one of these addresses takes 2 bytes, so 288, 290, 292, etc. We'll get into a little more of that later. So we've got an analog input module. Now I'm going to do an analog output module. And once again, here's some nice 4-point by 12-bit output modules. That's probably sufficient. These 16-bit output modules, you're really not going to get that accurate. Even though it says 16-bit, you're not going to be putting out the full resolution anyway. So we're going to go ahead and pick a 12-bit. Again, resolution is something that we would cover elsewhere. So my addresses here are PQW 304, 306, 308, and 310. Again, byte based, so it takes up 2 bytes per address. And that should probably do it for this configuration. That handles the hardware configuration at this point. If I want to, I could close this hardware, or, and that maybe I'll do this in the next video, I can open the simulator right up here and go ahead and download this hardware configuration. So I think that we will do that. That should be the end of this video, but I'm going to be kind of continuing right along here.